All right, welcome everyone. I'm going to go ahead and get started since we're at the top of the hour. First, I want to say good morning and welcome everyone to the March California Nevada Drought and Climate Outlook webinar. Thank you that have joined us before and those that may be joining us for the first time. My name is Amanda Sheffield. I'm from Scripps Institution of Oceanography in San Diego, and I'm the Regional Drought Information Coordinator for NIDIS, the National Integrated Drought Information System, and my region covers California and Nevada. This bi-monthly webinar series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. This webinar is being recorded. The recording, along with a 2-page summary flyer, will be up on drought.gov. The recording sooner, but probably the 2-pager later next week. Before we get started into our great speakers that we have today, I just want to give a little background for those that haven't seen this before on the National Integrated Drought Information System. We work to provide a better understanding of how and why drought affects society, the economy, and the environment. And this helps us to improve accessibility and use of early warning information for drought risk management. We've been doing that building off regional drought early warning systems, working towards creating a national drought early warning system. A drought early warning system utilizes new and existing partner networks to make this information available, and they're partners such as folks that we have on the webinar today, who I'll introduce in a few minutes. And with that, in California and Nevada, we have specific pieces that help us reach those goals of getting information out to stakeholders and decision makers, including the strategic plan, an upcoming fall workshop that we're going to work together to do coordination across this drought early warning system. We had one last summer, which was our first one, and it's hopefully will be an annual event. And we also have quarterly key stakeholder calls where we talk about current conditions and opportunities to coordinate better together. If you're interested in joining us for any of these pieces, please feel free to contact me, and we can get you more involved with the drought early warning system. With that, I want to get us back to the main topic we're having today, which is the current conditions of the drought. Rain, snow, impacts rangeland is what we're going to be talking about today. To go through the agenda, I'm going to be the first speaker. If you've been on these webinars before, you know we usually have a drought status update outlook. This time we've shortened that part a little bit so that we can really dig into snow drought as we're approaching April 1st and how rangeland and forage conditions are doing. And with that, I'm going to go ahead and get started because I'll be the first speaker. So here's what current drought conditions are sitting like in California and Nevada. On the left, you'll see the U.S. Drought Monitor from March 20th. You can see drought has creeped back up into California and Nevada. A lot more of the area is just abnormally dry, but moderate drought, severe drought, and a small area of extreme drought in that south central coast have come back. Most of these changes took place about 4 to 8 weeks ago, so in February when we were so dry, and have stalled a little bit in March as we've had wetness come inside. But you can see on the right-hand panel here is examples of how, since December 26th, of drought that has entered back into California and Nevada. As of right now, Nevada, 13% of the state is moderate drought, so those tan colors, and about 48% is in moderate to extreme drought, so these tan, orange, and red colors. Walking through us a little bit between what happened in February and what's been going on in March. So in February, we did have continued below normal precipitation. Here in the figure to the right is the percent of normal precipitation. You can see a lot of reds up to some of these orangish colors, which are 50% or less here of percent of normal. And temperatures, depending where you were either cooler or warmer, as it was in a lot of California. So some areas did reach their record driest in February compared to normals. And this is a figure that we've been working with CNAP, which is the NOAA RESA program here, and the Western Regional Climate Center to look at, based on what precip has been falling, what's our likelihood of reaching a median water year? So basically at the start of every water year, every one of these different stations start at 50-50. They have a 50% chance of reaching their median. And throughout the year, they've been tracking how well they've been doing. And as of after the little February storm we got, and based on the historical record, this is where some of the stations were standing out. We see a lot of these areas were well below 10% chance of reaching a normal median water year, while some areas still were in the 20 to 30%. February was rather dry, and this continued until we got into March. Here I'm just going to show you some integrated water vapor from the storm last week. These are plumes of moisture that are headed towards our coast, which is then what interacted with our topography and where atmospheric rivers and dropped the precipitation here. So in March, we obviously had a couple of these events that were more atmospheric river-like, and others where just the moisture came towards the region and gave us some wetness. And so in March, these several storms did get us in some areas to above normal precipitation for the month, not for the water year, just for the month. These maps are through March 24th, so yesterday. Here you can see percent normal precipitation here, where some regions were still dry and below normal for March, but there were areas of wetness, especially in these purple areas here. And generally, we were cooler across the region as well. So if we look at those odds of reaching a median water year again from the Western Regional Climate Center, this was updated as of March 22nd. You see there's been some areas improving, especially here, the Central Sierra areas have improved, getting above those 50% areas. So they have a higher likelihood now of reaching a median water year, but then some of these other areas did not. So we still have low values in the Bay Area, down through the Central Coast. And currently, according to these historical statistics, San Diego has a 0% chance of reaching a median water year. We'll know more as March finishes out and what precip we have throughout the year, and as we move towards April 1st. I wanted to touch a little bit on how we did overall in the water year. So here on the left is the percent of normal precipitation for the water year, so since October 1st. And you see, even with this wet March that we've had, we still have a lot of dryness in the area. So these red areas we're still below normal, and some of these, a few areas which are from some of the gains this month have gotten to slightly above normal area. We've heard a lot of chatter about, is this a miracle March? Should we be calling it that? And our answer to that is probably no. We've been comparing this to what was the last considered real true miracle March, which was 1990 to 1991, which is this red line here on this figure here. This plot looks at the Sierra Nevada total storage. It's from SNOBOT, which is an experimental project coming out of UCLA, and looks at the day of the year. And so this year is this blue line right here. So when you compare it to this 1990, 1991, which is one of our more miracle March years, you see we're not quite getting up to those amounts, and we're still below normal, which is the gray shaded areas. We're obviously have improved this month, but we're not quite doing as well based on the deficits that we've had earlier this year. We will have a speaker on snow drought more after this. Ben Hatchett will be the next speaker after me. He'll dig in more into this topic. A little bit more about how are the water resources doing. They're doing pretty well. On the right here are the reservoir conditions for California from the California Department of Water Resources. You can see most of these are at or above their historical averages still. On the left is a figure by CNAP, the NOAA RESA program, that looks at how reservoir normals plus snowpack normals compare to what's actually been going on this year. Doing this reservoir plus snowpack gives us a more holistic look at the entire system overall. And this yellow line is that reservoir plus snowpack together this year. As you see, we've had gains in March, so starting March 1st right here. The line's been going up while reservoirs have reached about their normal peak areas, but we're still below normal. And so this is a good way to track how we're doing throughout the water year, as well as how the water resources are doing with the snowpack. Now to move a little bit looking forward, so this is the Drought and Climate Outlook section. Right now, just to give an El Nino Southern Oscillation update or ENSO update, we are likely transitioning from La Nina conditions to ENSO neutral, 55% chance in the coming March to May. Neutral then is likely to come back in the second half of the year. Here on the right are a bunch of different statistical and dynamical models that are forecasting whether we stay in La Nina or neutral conditions. And going forward here, you can see a lot of these models throughout the summer into early fall are in this neutral category. So as we get closer to that time of the year, we'll start to look again and see what fall conditions are coming up. But for right now, they're projecting us to move out of La Nina into more neutral conditions. And then here are the CPC forecasts. So it's from NOAA. Right now, we're just looking at the April. What are the probability of above or below normal temperatures and precipitation. Here on the left is the temperature probability for April. You can see California, Nevada, we're looking at have higher odds of warmer than normal temperatures. If you remember, these areas are shading the most likely category. So here, for example, in this above normal temperatures here, it's about 40 to 50%. That means have higher odds of above normal temperatures occurring, although normal and below normal temperatures can still happen. They just are not favored as much as these above normal temperatures. And then the same is true for precipitation. We're favored right now to be below normal precipitation in April, though we still have some likelihood that we could go above or equal or normal precipitation. We're just favored to be below normal precipitation. Looking more seasonally now to April, May, and June, we see similar patterns above normal temperatures and below normal precipitation. This is just a little bit more for you have in your back pocket going forward. So these are the stream flow forecasts. Here on the left, these are from March 1st, so before we had some of these precipitation. But the NRCS on April 1st, or just right after, will come up with their next set of stream flow forecasts for the Great Basin in California. Back on March 1st, we were looking more at these below average conditions. And if you look at the California Nevada River Forecast Center, some of those are still true. You can see these oranges and reds here and the more updated information. But come April 1st, you can check out both of these resources to know what's the updated stream flow for what the snowpack we have gotten at the end of this month. And then lastly, this is just the drought outlook. So this uses information from the CPC and what the current U.S. Drought Monitor looks like. And currently over California, Nevada, the drought that is here is expected to persist, and drought development possibly here in these southern Nevada, southeastern California areas. And with that, I'll just quickly summarize where we've had drought expansion in California, Nevada in the recent months. Precipitation and snowpack still remain below normal in much of the area, though it's localized how much improvement happened this month. The odds are in favor of a warmer and drier than normal April, May, and June. And one thing we want to remind folks on the call today is to start reporting drought impacts. Also, we've had some things over the season throughout this year while we were still dry. We don't always have to wait till April 1st to start to hear about things. For example, with snow, we are hearing different tourism and recreation impacts going on throughout the season. So we just want to remind you to submit those drought impacts either to me. There's a drought impact report out there through the National Drought Mitigation Center, for example. And based on some of the feedback we've gotten this season, we're going to be launching a new snow page soon on drought.gov to sort of pull some of the snow resources together, but also put a simpler, more user-friendly drought impact reporter form on there so we could hear a lot more what folks were thinking about had happened this year with recreation and tourism, all leading up to March as well. So with that, I'm going to pass it on then to the next speaker. I forgot to mention to folks on the webinar that you can type in your questions. I'll try to get to some right after the speaker if I can, but otherwise we'll save them for the end. And Ben, are you there? I'll go ahead and pass sharing over to you.
Cool, I'm here.
So our next speaker is Ben Hatchett. He's going to talk more about the snow and snow drought and some of the work he's been doing with that. And he's a scientist from the Desert Research Institute in Reno, Nevada.
Cool, thank you, Amanda. So I'm going to talk a bit about our somewhat crazy water year of 2018. We're in California, Nevada, where we've seen essentially all of the above in terms of snow drought with respect to impacts and some of the causes from it. And so we'll start off by showing what the typical year looked like if you were to go to the NRCS SNOTEL page and look at snow water equivalent percentiles throughout the West. And this is kind of most of the days this winter, if you pulled this page up, you would see a lot of red on the map, which makes many of us not very happy. That implies that we are in the bottom 25th to 12th, or even at the very, very bottom of the percentiles in terms of the snow water equivalent for much of the winter. We can kind of see a classic La Nina type pattern here where we have above normal conditions in terms of snowpack far in the Pacific Northwest and Intermountain West in Montana and Wyoming, whereas much of the central regions into the Pacific Southwest were well below normal throughout much of the winter. So this was a not very good situation throughout much of the winter and kind of led to a lot of worry and concern, which hopefully much of which has been somewhat remedied by the recent precipitation in March, as we'll get to. So kind of a classic view from the airplane of what much of the Sierra looked like throughout throughout winter this year. Coming on the heels of our record dry winter, December, January, and February were very below normal. So flying over the Lake Tahoe Basin, we saw some almost beach-like weather on the left-hand side of that's showing South Lake Tahoe and Heavenly Ski Resort. You don't see a whole lot of snow there. On the right-hand side, we can see Diamond Peak Ski Resort on the northwest shore of Lake Tahoe, looking eastward into the Great Basin, where there is almost no snow to be seen. And so we were throughout much of the winter, we were having some pretty significant recreation and tourism impacts on the economy from people not showing up to go skiing as a result of our very low snowpack. And I think some of you more ecologically minded folks are probably also wondering what the impacts of the lack of snow on the forest ecology would have been. And we're very interested to hear your thoughts on that, because that's one direct impact of the snow drought situations is when we do not have snow, how are these processes changing? So as a result of these low snow situations throughout much of the year, there was becoming a lot of interest in the media, which nicely coincided with the release of a couple different publications that we'll have a few links to in here, and I'm happy to share with any of you as well. Essentially, we were falling into a deep snow drought, which was creating challenges for a variety of sectors of the economy and ecosystems. So then to define what snow drought means, Dan McAvoy and I just recently published a paper on the origins of snow drought in the Sierra Nevada. And snow drought, essentially, you can think of it as any time that we have below average snow water equivalent at a given point or place in the mountains for a given point in time. And the separation of the types of snow drought, there's two main types. There's the dry snow drought, which is when we have below average snowpack and below average precipitation. So you can think of that as kind of the classic drought definition. However, there's a more interesting definition that pops up, and that's the warm snow drought scenario. And that's where we actually have above average precipitation, but below average snow water equivalent. And so the graph on the upper right-hand side shows the two snow drought regimes, where in both cases we want to be below the 100% of median snow water equivalent line, so that basically below that 100% line that cuts across. And depending on our percent of normal precipitation, that defines whether we're in a dry snow drought, such as 1977 or 2015, the blue and brown dots, or whether we're in the warm type snow drought, which many of the other years on the graphic show, where we had above average precipitation but below average snowpack. And something else that's particularly of interest is that elevation very much matters as well, and we can kind of see that looking at particularly these warm type snow droughts, where the scatter of the dots for certain years spans snow drought conditions, but also perhaps above average snowpack conditions. So like the years of 1970 on the bottom left side and 1997 on the bottom right side, where at the highest elevations we had above average precipitation and above average snowpack. However, at lower elevations we had below average snowpack. And so we'll discuss how that played into a bit of a role this year in our snow drought in the Sierra Nevada and Nevada. So looking at water year 2018, we'll kind of chronologically walk through that. This picture is of Squaw Valley in, I believe this was early to mid-December, kind of a typical view of what things were looking like, where there was a little bit of snow up high, but then very, very dry conditions down below, and a notable lack of snowpack, which is quite anomalous for that time of year. So the early season, basically looking at the first 2 months of the water year, so October and November, the next set of graphics that I'll show all come from the Climate Engine, which is a very handy tool for spatially displaying weather and climate conditions throughout the United States. If we look at precipitation anomalies on the left-hand side of the screen from the University of Idaho GridMet product, we see that this was actually a somewhat wetter month in the Northern Sierra, Northern California, and Northeastern Nevada and Western Nevada, but very, very dry to the south. Snowpack anomalies on the right-hand side come from the SNODAS product, and we see that for the most part, we were doing pretty okay at the end of November in terms of snow. You see a little bit of green, so we had a little bit above average snowpack in the central higher Sierra regions, kind of from Mono Lake to the Tahoe Basin. The northern Sierra was a bit below average due to the high snow level storm event that gave us much of our precipitation. And I've masked out the SWE differences from average that are on the order of plus or minus 25 millimeters, so you don't see that in there. So we're really just looking at the bigger differences from average. Then moving into winter, very, very dry December, January, and February, as shown on the left-hand side, where we were well below average throughout the region due to the anomalous blocking high-pressure ridge that diverted all of the storms to the north into Washington, British Columbia, and Montana, and more of the northern Intermountain West. And as a result of that, at the end of February, looking to the right-hand side, we see that we were deep into below average snowpack conditions from the southern Sierra all the way into the southern Cascades and throughout much of Nevada, the Nevada ranges as well. So we were many, many millimeters anomalous in the negative direction throughout much of the Sierra and for much of the winter due to the lack of precipitation that took place. Things dramatically improved during March. These graphs are through the 22nd of March, when the last point that this data was updated. We can see, similar to what Amanda showed, where we had about 3 really good storm events come through, 2 of which were notable atmospheric rivers, basically the last 2. And so that produced substantial precipitation throughout the central coast of California and throughout much of the Sierra Nevada and into the northwestern and northeastern parts of the Great Basin and Nevada. Still a little bit below average in the southeastern portion of Nevada into the southern regions of California and into Arizona. Those anomalous precipitation events led to a pretty substantial improvement in our snowpack. So we can see, looking on the right-hand side now, that much of that brown area from the previous slide, I'll go back there real quick, has somewhat dramatically improved in terms of snow water equivalent. Still below average in many regions, but we did make a very large dent in the snow deficit and subsequently in the magnitude of snow drought conditions. And then just as a result of those colder storms that we've been having, you can see that there has been some anomalous positive differences in snow water equivalent for some of the lower elevations, particularly in the western slope of the Sierra Nevada and some of the regions in the southern Cascades. So if we look at more of a chronological discussion, which is something that Dan and I recommended in a recent paper on snow droughts, that it's really important to look in terms of essentially the daily time step to really characterize how snow drought originates, how it terminates, how it evolves in time, and how those changes and evolution can potentially impact both sectors of the economy, recreation, and ecosystems. So if we look in terms of a few different sites at varying elevations here, so we'll first look at Fallen Leaf Lake area, which is just to the southwest of Lake Tahoe at approximately the Lake Tahoe elevation. And here we're looking at the SNOTEL station, going back over the course of the water year and looking at liquid equivalents. What we see is at the beginning of the year, and I think my mouse will show up here, so we can see this early season mid-November event that was produced quite substantial precipitation. However, high snow levels during that storm resulted in no snow accumulation at the lower elevations. And so we see that the snowpack for the year, the blue line, was at or well below normal throughout much of the early part of the winter, because we did not accumulate any precipitation during that first event. And so as a result, for much of the beginning of winter, lower elevations were in warm snow drought, where we had above normal precipitation, but below normal snowpack. This was followed by a persistent dry spell, which then drove us into dry snow drought conditions, starting right about at the turn of the year, where we had below average snowpack, and note that there was almost no snow, or was no snow at low elevations for much of the winter season, and below average precipitation. That was to some extent remedied a bit by our March Madness or Miracle March, where we see a substantial increase in precipitation accumulation during the last 3 weeks, and we did accumulate some late season snowpack. So now at this point, if you were to look at fallen leaf lake, you would see that we are well above normal in terms of snowpack and precipitation. Moving to a higher elevation location, now we'll look at Mount Rose Summit, which is to the northeast of Lake Tahoe in the Carson Range. This is a much higher elevation station, about 2,600 feet higher. Again, we see our big early season precipitation event. Much of this came as snow, which set us off to being in a very good start to the year, where we were above average precipitation and snowpack wise. However, our persistent drought conditions eventually led us into a dry snow drought onset, where we fell into below normal precipitation and below normal snowpack, which lasted throughout much of the winter. And currently we are still just barely in the dry snow drought conditions, although we're probably close enough to normal in terms of snowpack and precipitation that we may not view this as much as a snow drought at the current point in time. But that's a really important point, is with both Mount Rose and Fallen Leaf Lake, that if we use a singular point in time definition of snow drought, say April 1, and you look at Mount Rose, you may totally miss the fact that much of the season was in snow drought, and that may come with impacts that could potentially be ignored. And so anytime you use a single point in time, you might miss what's happening or happened earlier in the year. And so it's really important, we think, to look at the whole year in context to see how the snow drought conditions evolved in time, and if we went from different kinds of snow droughts back and forth, or finally exited snow drought conditions, just to fully be able to quantify the different types of impacts. Moving now into the mid-elevations of eastern Nevada, so this is looking at Lamoille Canyon in the Ruby Mountains. We see a scenario very similar to the Sierra. We had that initial big storm event here in mid-November that produced a lot of precipitation and some marginal snowpack gains, but then that was followed by the dry period, which then drove us into a brief episode of warm snow drought with above average precipitation and below average snow. The persistent dry conditions then drove us again into the dry snow drought, where we had below average snow and precipitation throughout. In central Nevada, the story was similar, but a little bit different, in that we again had a warm snow drought to start, which then transitioned into a dry snow drought. But at these lower elevations, there was almost little to no snowpack accumulated and existed throughout much of the early part of winter, which may have some interesting impacts on some of the rangelands and mid-elevation regions in the Great Basin overall. And so that's an interesting question that we're actively exploring, is how these low snow conditions during much of the peak meteorological winter may have impacted the Great Basin systems. So just to talk a little bit about the Miracle March that we've been seeing, or is it a Miracle March? Looking at Donner Summit from the Central Sierra Snow Lab SNOTEL, where we have 35 or so years of data. On the left-hand side, if we look at our precipitation accumulations, each line shows the precipitation trace throughout March for all of the available data. The lines are colored by the change in rank of the precipitation year from the start to the end of the month. So the green lines indicate that there was a positive change in the ranking of how wet that year was, and the brown lines show that there was a decrease in ranking of how wet that year was. So brown lines implying that there was less than normal precipitation, so we actually dropped off in the rankings. Green lines showing that there was an improvement in the total water year precipitation. And we see that 2018 falls in at rank number 5. So it was a good March. It wasn't the best of March and wasn't a spectacular one, but it was certainly a very good one. And we did see a large increase in the precipitation rank of about 10 places throughout this period. So it was a very helpful March. You can also see 1991 for reference on there as well as being a little bit better. There was essentially one more good storm that came through in 1991, which given our current forecast does not look likely to take place at this point in March. So most likely our March is going to end up being about the rank number 5, although if we do get a little bit of precipitation at the end of the week, we may surpass 2011. Moving to the right-hand side and looking at the change in snow water equivalent over the month, this figure shows the plume behavior of the snowpack in that some years we decreased our snowpack and actually lost snowpack throughout the month, and other years we increased our snowpack, and thankfully this month we had a very good increase in snowpack, and so we did make up some substantial ground this month, which was very, very good to see, both for people who like recreating in the snow and people who like having snow in the mountains available to melt and refill reservoirs and keep stream flows going. So it was very nice to see this accumulation trend during March as opposed to a decline in the snowpack. Looking now at the snow water equivalent versus precipitation percentiles for the month, we can see that 2018 is kind of not nearly as bad as it was if you had picked many of the other points in time for the month, that we would have been much further down and to the left-hand side. Now we're at about close to average precipitation, right near the 50th percentile. Precipitation-wise, we're still in the bottom tercile of snow water equivalent for the year, very similar to 1991 for the point in time. But of note is how much wetter this year has been compared to 1991, and that is primarily due to that initial very wet storm in mid-November that drove us further over to the right-hand side. And it's worth noting that the snow lab is located at about 7,000 feet, where much of that first storm came as rain, so we did not get that snowpack accumulation. Had that initial storm came as snow, we probably would have been pushed further up closer to that 1-to-1 dashed line and been kind of right about average for this point in the year. Those snow depth differences from late February to late March, we can really see the improvement in the snow depths from SNODAS again throughout much of the Sierra Nevada, particularly at low elevations. From SNODAS here, we can see that especially along the western slope of the Sierra, we had substantial improvement in snow depth, and also along the crest, although we are still below average at many of the higher elevation locations as well. So one question in regards to the impacts came as a result of the low snow conditions that took place throughout much of the winter. And here looking at Tahoe City, we can see that much of the temperatures throughout this winter were normal to well above normal, even setting some records in December and in February. But I want to point out this very cold spell that took place kind of at the end of February and into early March, where we had almost no snow at many elevations, and we were in the very, very cold, not quite record cold, but quite cold conditions. And that brings up the questions of what kinds of impacts may there have been of this cold spell on ecosystems that normally have an insulating snowpack, but at this point did not. And that's a thing that we're going to be on the lookout for to see if there's any negative impacts for, say, vegetation or for the critters that like to live under snowpacks or having that insulating snow to be able to exist happily in. So in summary, this has been a very complicated year so far. Our best effort to describe it is all of the above, where we've seen elevational gradients of snow droughts, we've seen warm snow drought transition into dry snow drought, and dry snow drought at upper elevations, largely due to that persistent dry winter that we saw. March gave us substantial snowpack gains throughout much of the region. We're still close or in dry snow drought, however, it is not nearly as severe. We're interested in the ecological impacts of the cold snap with no snow, and is also looking at the recreation and economic impacts of the lack of snow during much of the holiday period and some of the more popular times to recreate in the snow. And that's some work that's ongoing with the Winter Wildlands Alliance. So with that, I'm happy to entertain questions at the end, and thank you very much.
All right, thanks, Ben. As I said, people are typing in their questions, so we'll save most of the big ones for the end. While I'm changing speakers, there's a quick one. Can you explain what snow water equivalent is? I think some folks weren't quite sure what they are.
Yeah, sure. So snow water equivalent is essentially the amount of liquid water stored in the snowpack. And so you can think about if you walk along a snowpack and you were to push a pipe into the snowpack and pull out a column of snow and then melt all that snow down, the snow water equivalent would be the amount of liquid that you have melted out of that snow. And so in the Sierra Nevada, we tend to have higher snow water equivalents due to our more dense and high density snowpacks than in many regions in the Intermountain West or other continental regions, where the lower density snow means that for the same snow depth in the Sierra Nevada and parts of Nevada, we'll have a lot more water equivalent there.
All right, thanks, Ben. I'm going to move on to the next topic then. So when we were going through in the last couple of months, we started to hear about rangeland impacts through the U.S. Drought Monitor, listservs, and things like that. So we thought it'd be good to devote quite a bit of time on this webinar to that as well, to talk about how California and Nevada have been doing. So that's what our next three speakers will be. First is going to be Jen Balakowski from the USDA California Climate Hub, followed by two speakers, Leslie Roque from UC Davis, who's a cooperative extension specialist, and Catherine Dyer, who is from the Nevada BLM Range Program. And with that, I'll let Jen take off.
Thanks, Amanda. I'm Jen Balahowski, a postdoctoral fellow with the USDA California Climate Hub. For those who don't know our organization, our mission is to connect researchers to practitioners in agricultural sectors to encourage more climate-smart land management and more resilient agricultural systems. We've got 10 locations across the country. The California hub where I am is at UC Davis. And the Southwest hub that serves Nevada is at the Jornada Range in Las Cruces, New Mexico. So my talk today is going to be a little bit different in that it deals primarily with expectations of future conditions on California rangelands. And I'm going to be presenting on a report that we've produced called the Climate Vulnerability Assessment of California Rangelands. Let's see. There we go. So the actual report consists of 6 chapters that are shown here, but since my talk's really quick today, I'll describe briefly the contents of just chapters 1 and 2, including some mid-century forecasts of water stress on rangelands. You will be able to read very shortly the final report at the Climate Hub's website, which is linked on this slide as soon as it's through USDA's final review process. So to start off with that intro to rangelands, California rangelands provide roughly 31 million acres of forage for cattle, sheep, and goats, accounting for almost a third of the state's total land area. Excluding dairies and other confined livestock operations, beef cattle make up by far the largest portion of our livestock industry, with over 19,000 operators generating over $3 billion in revenue annually. Beyond food and forage, rangelands and ranchers provide valuable ecosystem services to virtually all Californians, including habitat for native plants and animals, improved water quality, and also open space for recreation. But drought reduces forage availability in rangelands. So as you can see from these photos, comparing the same rangeland site in 2006 and 2014 at the height of the recent drought, much less forage on the right-hand side. But these drought impacts are not evenly distributed across the state. During the recent drought, Northern California, which generally has more consistent rainfall, maintained above 50% of its average annual forage production, while some arid rangelands in Southern California and in the rain shadow of the Coast Range experienced declines to as low as 5%. And since water availability is so varied across the state, our vulnerability assessment includes several spatial analyses of mid-century climate and water stress. For example, this map from our report shows changes in climatic water deficit, which is a proxy for plant water stress, under a more extreme warming and emissions scenario. In general, what you can take from this map is that rangelands are expected to be drier, as indicated by the warmer colors, but with substantial variation in magnitude across the state. We also forecasted climate change exposure. Exposure is a measure of how extreme a climate change is expected to be relative to a plant community's historic tolerance. For example, you'd expect desert rangelands to tolerate drier conditions than coastal prairies. So on this map, which is also one of many in our report, we defined areas of critical exposure as those in which climate conditions will become more extreme than those experienced in 95% of a plant community's current distribution. Here, green indicates less exposed, and red and black are both areas of critical exposure. So since there's not a lot of time to process all these maps that I'll show you today, you can just think of red being bad and green being better. Now I'll give you a few examples of how we interpreted these exposure results. So first, we calculated exposure for different rangeland vegetation types. For example, our report found that 48% of hardwood rangelands may be critically exposed by 2069, while the most exposed rangeland vegetation type was desert woodland at 71%. Next, we factored in use in order to consider the actual impacts of climate exposure to ranchers. So sticking with hardwoods and deserts as a comparison, while exposure is higher in the desert, the actual impacts on ranchers may be greater in hardwood woodlands because they're more heavily used for grazing. And finally, we provided county level exposure scores in the context of beef cattle inventory. And this is because many of the programs California ranchers depend on, such as cooperative extension and the resource conservation districts, are administered at the county level. So here we can see just a couple of the top beef producing counties that vary pretty substantially in their levels of climate exposure. So some quick take-home messages from my brief intro today. California rangelands are likely to be drier. And secondly, ranchers are likely to be faced with the prospect of less forage, though these future drought effects will likely vary substantially spatially across the state. We also stress in our report the importance of considering water stress in the context of use and at scales that are relevant to managers. And with that, thanks for your attention today, and thanks to all of my co-authors, some of whom are shown here, and one of whom, Leslie Roche, is up next. Check out our new .gov website in the coming weeks for the final report. The link is at the bottom of this slide. And I'm pretty sure you can just Google California Climate Hub, and if not the top hit, it'll be one of the top 3, I'm sure. So yeah, thanks a lot. And as Amanda said, I'm happy to take questions at the end of the talks today.
Great. Thanks, Jen. With that, I'm going to pass it over to Leslie to go next, talk about California.
Sorry, Amanda, can you see my screen now?
Yep, perfect.
Okay, great. So then I'll start. Thank you. So as Amanda said, my name is Leslie Roche, and I'm a cooperative extension specialist based at UC Davis, but I have a statewide appointment. And for those of you unfamiliar with cooperative extension, which I hope isn't many, cooperative extension, in general, it's a partnership between the land-grant universities, the USDA, and state and local governments that really facilitates research and outreach in agriculture, natural resources, and communities throughout the states through science-based public programs. And so today I've been asked to give an update and talk a little bit about the ongoing and developing drought impacts to California's rangelands specifically. And so in preparing this information, we did a qualitative survey last week of all of our cooperative extension partners, specifically those whose programs focus in livestock and natural resources, as well as some of our partners in the NRCS and local offices. And so I'm going to step through several slides here. I've divided up some of the information that we've received so far, generally into bioregions, and I'll call out specific counties with some more specific quantitative information that we've received so far. And so just starting with northeastern California. So largely we're looking at Modoc and Lassen counties here. These typically are perennial grasslands and shrublands. So right now it's still a little bit early right now in the season to kind of predict what the impact will be. They are seeing some spring green up to date. And of course, last week's storms, as well as the next 5 to 6 week window of precipitation, will be critical in determining what the impacts will be for the season. Right now, they're predicting that the earliest turn-on dates for the federal lands, public leases, will potentially be about mid-April. So that's for northeastern California. So we travel to the west over on the north coast. So here we've got Humboldt County and Mendocino County. Again, it's still fairly early for many of these areas, with some still under snow. They have in lower elevations seen forage growth above average, considerably so for many of the monitoring sites, and spring flow has been normal to above normal for most areas. And most of this information is coming out of the Eureka NRCS office. We move to the Sierra foothills, which we just heard a little bit about in terms of their vulnerability. They've actually been experiencing a fairly good year. They have above average forage production for the season to date so far. In fact, some sites are reporting as much as 230% of average forage production. What they are seeing is a potentially very early peak production. And so this could have impacts in terms of the length of the grazing season. They might potentially have to be moving cattle earlier than expected, because the forages are significantly in advanced phenological stages than normal. For the Sacramento Valley, it's actually been highly variable. There's been a lot of spatial variability reported this year, more so than what's been seen in the past. In the northern Sacramento Valley, which includes Tehama, Glenn, and Colusa counties, they've seen severely reduced forage production pretty consistently since about October. ET has exceeded precipitation, and so they continue to have concerns there. However, their neighboring counties, so Shasta, Butte, Yuba, and Yolo County, which is where I'm located at UC Davis, although we've had sporadic early season rainfall, there's generally been normal forage conditions, and particularly so now with these most recent storms last week. We're looking at a more normal year. Moving over to on the west side over the Bay Delta region, so southern Mendocino and Sonoma counties, various reports of below average to normal conditions. They have had a fairly productive forage season so far, with some folks reporting that they've had some carryover effects and impacts to that forage, though, from the 2017 wildfires, where those fires hit. And then moving to the San Joaquin Valley, so this area here that my arrow is hovering around, in general, the early season has had very low rainfall, as we heard earlier. Ephemeral creeks, intermittent streams are not flowing in many areas as reported. In the San Joaquin and Stanislaus counties here, they are seeing about 30 to 40% of forage production, so 30–40% of normal. A little further south in Fresno and Madera counties, as of March 7th, so this is a little bit dated. They did have some rainfall last week, of course. They only had about 7 inches total to date. This region, their average is typically about 20 inches. And so they did have some operators who were implementing parts of their drought management plans and were feeding hay. They also had some folks north of there in the San Joaquin County were actually shipping cattle about 2 months early. In northeastern Kern County, what we're seeing is, general lack of rain and cold temperatures has resulted in some stunted grass growth. And so, and across all these counties here in the San Joaquin Valley, we're hearing pretty consistent reports of early peak production, which is potentially contributing to some of those earlier almost 2 month earlier shipping dates that folks are reporting. So overall for the San Joaquin Valley, low forage production and a much earlier season. The central and south coasts, particularly in San Bernardino, Monterey, and San Luis Obispo counties, they saw very dry early season conditions, with many ranchers reporting they were considering implementing their drought strategies. However, in the past week, they did receive some substantial rainfall, which did result in some some green growth, and particularly in San Benito and Monterey counties. So it looks like the, in general, the recent precipitation has mitigated some of these impacts. So that's reports from the field so far. We're still gathering information to send out to folks. I just want to recognize the many cooperative extension advisors and InterCS partners that helped in pulling this information all together. And I can take questions now, or of course, as Amanda said, toward the end, we might have some time. Thank you all.
Great. Thanks, Leslie. It's good to hear that some of the rain has helped some of the impacts we were hearing before, but there's still seems to be a way to go for some of these regions.
Yes, definitely.
Yeah. All right. We're going to go to our last speaker, who's going to talk similarly about Nevada. Catherine, are you there?
I am here, and I do have a short PowerPoint that I did not send you earlier, so if you can tell me how to do that.
I just sent control over to you, so you should be able to pop up your screen. We see your email right now. There we go.
Oh, you don't want to look at that. Okay, there we go.
Yeah.
So thank you for having me. I'm Catherine Dyer. I'm the Nevada State BLM Range Program Lead. And so I coordinate with the Range Program staff members in the field offices. And so I was not able to collect pictures from them about the range, but I thought they did give me some verbal information on what they're seeing. And you guys always have such wonderful graphics. I fall terribly short on that, but we'll talk a little bit just about in the range program why we do keep an eye on precip and drought. So the speakers from California have had great insight on that. They're a little bit different focuses since I work with BLM. We have, here we go. And I can't see the right-hand side, so hopefully you guys can see the entire screen from where you are. But so we have a grazing year that goes from March 1st through February 28th every year. And so that is inherently problematic in terms of March 1st being sort of an ambiguous time for what the growth of that year is going to be vegetatively. And so there's always some uncertainties and guesswork involved, but thanks to the perpetually refined tools that are available, we can get a better and better idea annually. We have nearly 700 BLM permittees throughout Nevada, and so these are public land ranchers that are all potentially impacted by drought and any other event that comes through the state. And just as a bit of reference, we don't have any numbers for for what we're expecting this year yet, but we do have about 2.1 million AUMs, that's animal unit months, so that's one cow for 1 month. We do have about 2.1 million AUMs permitted on the BLM grazing allotments in Nevada, and about 1.4 million was the average used during the last prolonged drought of 14, 15, 16. And so some of the things, again, since our grazing year is not ideal for when we have a really strong handle on exactly what the forage production has been for that year, pre-planning can be somewhat problematic. And so we can do split billing instead of charging permittees for the entire duration of their grazing season. We can say, well, let's plan this month and bill it out, and then we'll see what, April may bring, and then we'll, plan from there. That can be good for record keeping and for flexibility. That can be very difficult for a permittee to get a plan on what their business operation is going to be for that year. So it's definitely a time of great uncertainty for the permittees. And, thanks to UNR and NRCS, there are, and a variety of other agencies, there are drought relief programs. BLM does not administer or oversee any of those, but those are available for for permittees as well as non-public land ranchers. But some of the options that they can have in order to respond to these conditions are they could run less numbers. So maybe they run 50 cows instead of 100 cows. They could run shorter seasons. Perhaps it's only reasonable to graze 3 months as opposed to 5 months out of a particular year. They can do water hauling if the precip patterns have been such that, let's say, we have fabulous vegetation production and forage amounts, but we have very depleted stock ponds and surface waters, then they can actually, physically haul water out to various places in the area that may be missing that resource, and then complete rest when necessary, a variety of other options. So just wanted to remind everyone the BLM mission is to sustain the health, diversity, and productivity of the public lands for the use and enjoyment of present and future generations. So it is a perpetual balancing act of, using it now, saving it for later, and making sure that everyone enjoys it in the amazingly different ways that they all want to enjoy it. So it is a balancing act. Let's see if we can progress. Okay, so the drought impacts that we look at the most in the BLM range program are the water and the food. So reductions in water availability, are we seeing springs decrease or dry up? Then we're going to see a greater concentration of animals, wild horses, livestock, even wildlife. As there's less water sources, then the animals out there are going to be concentrated on the few remaining water sources. So we'll see, potentially great impacts in the disturbance and use of those. And then also the decreased amounts in the vegetative production. And so the forage amounts as well as the habitat values. And so trying to balance those. This slide is really boring, but plant physiology, we are recognizing that the drought has impacts on the vegetation both now and into the future. And so here's a slide just to give sort of a reference of what some of the range specialists have, been thinking about and looking at. So we have a variety of different types of vegetation out there, and we recognize that there's different rooting depths in the different types of vegetation. And so since all species have these different rooting depths, we recognize that, shrubs may be the most delayed in vegetation response to drought, since they're able to capitalize on some water sources that things such as the shallow-rooted grasses or forbs may not be able to capitalize on. So we try to recognize that there are different impacts throughout the different plant species and record and respond to those appropriately. So the roots are really important for the plants. Obviously, with the reduced growth, we also get the reduced mineral uptake. And so this decrease in the root mass and the lack of root reserve replenishment can affect that plant for the years to come. And so those roots stratification slide from before, you'll see the more impacted these plants become, the greater discrepancy in response you'll see between those as those sort of stratifications are exacerbated. Whoa, there we go. So some of the things that the range specialists will look at is reduced growth of these plants. Are the buds dying off as, before they're even able to finish their cycle? Decreased flower and seed production and development, decreased germination, which obviously they're not always able to tell that. Decreased root reserve replenishment, increased susceptibility to pests and pathogens. And so not only will we see the immediate responses, but depending on how we manage those, we can see some pretty severe responses in the years post-drought as well. And in Nevada, we're always either in drought or post-drought pretty much. And then the grazing in drought, we do want to make sure that people recognize that, that these impacts are these impacts are real and can be good or bad depending on how you do it. And so grazing is not inherently bad, but done incorrectly at the wrong time, it can have negative results. And so we try to be sensitive to what the ranchers need to stay viable, but also what the ecological needs are in order to stay viable for the long term. And so basically, this is a classical slide you guys have probably already seen, but there has to be some amount of photosynthetic material in order to be able to produce a root mass that is capable of capitalizing on those water resources when they are available. And so going into a drought with already poor conditions will just lead to even more depauperate conditions of your forage resource throughout that drought. And so the bottom line, try never to overgraze during a drought because you will have impacts not only then, but into the future. And you will you will allow that space for your invasive species to increase as well. And many of those have evolved in some very, drought-stricken areas, and they're very drought-tolerant, plants and propagation strategies in those species. So we try not to leave them openings to come in long-term drought. I think you guys understand that. So basically what I have been hearing from the field is that we did have, like it was mentioned earlier, there was the February-March cold spell. So we did have cheatgrass throughout the state coming up even in December. However, that, to my knowledge, did not, finalize its seed set and was frozen off prior to finishing that life cycle. So we are coming into now, I guess, the second flush of cheatgrass for the year as it starts warming up again. And I have gotten reports from throughout the state that they are starting to see the perennial grasses greening up and starting to produce new leaf matter. However, those are still at a very, very young stage of development thus far in the year. And so there could be, if we have another cold spell, we could see impacts to both the annual and perennial grass species. And basically, we are seeing at this point also ongoing impacts on the surface waters, not only with reduced flow in some systems, but also with the catch ponds, with the livestock reservoirs, that type of thing. I'm getting reports from throughout the state that they're looking at about half level. There's water in them, but they're by no means full. So a half to 3/4 levels, which could mean that those would dry up before the grazing season ended this year. And so there may be need for addressing depleted surface waters. But I think that is the end of my report, and I apologize for not having more beautiful pictures. So
no worries, that was great, Catherine. You don't always need the picture to get your points across, so I think it was great to know what you guys are considering and thinking about with that. Okay, I'm going to still control back here, and at this time, if anyone else wants to enter any questions in, there are a few to go through. Thank you to all the speakers today. They were great presentations, and it's interesting to hear as we've developed this webinar, started getting more and more into these deeper impacts and thinking about how things are doing or not doing, especially year by year, because every year is unique, it seems like. Before we go to the questions, I just want to say, just to remind you, a recording of this in a 2-page webinar will be coming out in the coming week. Our next webinar is scheduled for Tuesday, May 29th, since we do these every 2 months. Registration is already open on drought.gov, so you can register if you want. And I'll also send out the post-webinar email, which will send these the recording for the presentation and things like that out there. So if you missed any information, you can check out our YouTube and you'll be able to rewatch this again. With that, I can dig into a few questions. Let's see. One of them, and I think this one might go back to Ben, unless someone else knows it as well, is can you comment on the NRCS plan to not produce SWE maps for the West next year?
So I've heard the same thing, and while I think we're all sad to see those nice maps go, I believe they are adding some functionality to the interactive map that you can get to. I usually just get there by Googling SNOTEL map is kind of my cheat sheet way to get there. And from what I've heard, they are going to add some functionality to that in order to sort of make up for the loss of those existing pages. I don't know if they're going to do it in a basin average sense. I know the basin average maps are really nice and can be really helpful. But as far as I'm aware, we will get something that'll be of similar use, hopefully, out of it. Although I can't specifically state exactly what we'll get or what we will end up losing forever. But we're also kind of hoping, I've been talking with Dan McAvoy about trying to figure out a way to reproduce those same maps that are disappearing, and hopefully we'll try to host those on the Western Regional Climate Center pages in the future.
Thanks, Ben. And I think some of the other federal agencies are all talking to NRCS and seeing what's up and how they may help and things. So there might be some hope for them yet, but we'll have to see. Just add that there too. And then there's one more question, I think, again for Ben. Let's see. They were asking, Ben, your thoughts on might be in terms of, you talked about this a little bit, but in terms of ecological significance, short versus longer term, of a warm versus a dry snow drought. So basically what these mean ecologically on or to the system. I think you showed an example there, but if you want to add more comment there.
Yeah, and it's a good question because it's really what Dan and I were hoping to do with sort of better characterizing snow drought and how to define it and how to examine it, because looking at it in a sort of evolution of a season context should allow us to better ask and answer some of these questions. And I think, and maybe some of the ecologically minded speakers can chime in on this, but I think with regards to dry versus wet snow drought, there's probably going to be some differences with regards to plant water use and canopy water storage, possible changes in the timing and onset of wildfire conditions. If you have a lot of precipitation but not a lot of snow, you may allow some of this earlier green up and subsequent curing of fuels to take place, whereas in a just a dry scenario, overall, you may not get those fine fuels accumulating and curing as quickly. Other implications would be kind of sort of the longer term plant water stresses from if you don't get any water versus getting water in the form of rain rather than snow. The thing we're kind of really interested in is the lack of insulation of the vegetation and roots, shallow roots, from not having a snowpack. And I don't know if you have a dry snow drought, that may be exacerbated, because if you have a wet snow drought, at least you have that specific heat capacity of having water in your soil and making your soil a little less susceptible to getting very, very cold and then resulting in some negative impacts on the root matter. So I think those are a few, but as I'm not an ecologist at all, I'm just really interested in all of this. Maybe some of the other speakers have some ideas as well.
Nope, maybe not. All right. Thanks, Ben. That was a great answer. And obviously, as you said, it's something to dig into and talk to. And if anyone wants to talk to Ben further about that, if I can give his information, or he can contact Ben directly, we can talk about it some more. With that, we're past the hour, so I don't want to keep people too much longer, and I don't see too many other questions. Thank you again to all the speakers. We had almost 100 listeners this time, which has been great. And so with that, I'll go ahead and end the webinar. Thanks, everyone.
Thank you.
Thank you so much. Bye.